So those reactions which involve both the oxidation and reduction process. Okay. So now during the chemical reactions, what happens? Electrons will take part in the reactions right now. So some species will lose the electrons, some species will gain the electrons. For example, simple chemical reaction here you can write zinc reacting with copper plus 2 ions. Now what happens here? Zinc will loses electrons and becomes plus 2, and copper will gain the 2 electrons and become 0. Okay, I am writing this as one reaction, and the second possible way I am writing copper plus Zn plus 2 giving rise to copper plus 2 plus Zn. Okay, now what makes the difference between 1 and 2? See, is there any charge here on the zinc? What is the charge here? So now for any species, like if they are in the elemental state, see, like zinc is an element now, copper is also an element, but with some charge is there. So now for an element, if there is no charge, then the oxidation state of that element is considered to be 0. So now to that element, if there is any charge, then I can say it as an ion. Now whatever the charge present on that ion will be considered to be its oxidation state. Now what is the oxidation state of zinc here? And for this copper? Now what makes here it is becoming plus 2, 0 converted into plus 2. So what is this process called? See, losing the electrons or gaining the electrons? Losing the electrons or gaining the electrons? See, in chemistry, whenever there is positive charge is developed, it means what? That species lost electron. See, in chemistry what happens? Only electrons will participate in the chemical reactions. Okay, if electrons only participate in the chemical reactions means, what does it saying? Like electrons lost means negative charge are removed. So if negative charge are removed, now that species will have positive charges. Okay, now if negative charges are gained, it means electrons are gained means that species will have now negative charge on it. Okay, so these are normal chemical reactions. If anything inside that nucleus part is involving means we are calling them as nuclear reactions. So we are not studying about nuclear reactions now, now we are studying only normal chemical reactions in which electrons are involving. Okay, so now this species is losing the electrons now. How many electrons is lost? 2 electrons it is removed from here, so that's why it is positive charge. So minus 2 electrons, it means what I can say, loss of 2 electrons. Okay, so now this charge is increased, now you can say this process as oxidation. What is this process? Oxidation. Now from here to here, see, plus charge is converted into 0. That number is reduced now. By what process it is reduced? Whatever the electrons lost here, that 2 electrons are taken by this copper and becoming 0. Plus 2 minus 2, 0. So this process is called what? Reduction. During oxidation, what happens to positive charge? Increases. Like loss of electrons results to the charge increment. Okay, positive charge increment. Okay, and gain of electrons, see what happens to that positive charge number? Decreases. Okay, so oxidation means loss of electrons, reduction means gain of electrons. This is clear. Okay, so now here also I have written the same reaction in the different, like in the opposite manner right now. Here who is undergoing oxidation, I can say zinc, and reduction copper. So in this reaction both oxidation, reduction are involved now, so we can call this reaction as an example of redox reaction. Now here also this is also an example of redox reaction, fine, but out of these two, which is feasible reaction? What do we mean by feasible? Which is a possible or a spontaneous chemical reaction? First one or second one? See, here zinc is undergoing oxidation, copper is undergoing reduction, but here copper is undergoing oxidation, zinc is undergoing reduction. Opposite of this I can say. Okay, now out of these two, who is possible, like which is feasible or which is a spontaneous reaction I am asking? So here it is first one. How can we say this? So now this each element is there now. So each element will be having some ability, like its individual ability. Like see, in the classroom, some person will be topper, someone will be mediocre and duller, like that we know, okay, and some students will be overreactive and some will be keep silent, like that. Every element also have their own characteristic properties, okay. So now here zinc has ability to lose the electrons compared with the copper. So if zinc is having more ability to lose the electrons, it will easily give the electron that will be taken by copper plus 2. Okay, so now the ability to lose the electron or ability to gain the electron is there now. So those are considered to be their potentials. What is it? Potential. So if zinc is losing the electrons means what is happening here? Oxidation. So the oxidation potential of zinc is more when I compare with the copper. That's why zinc is losing their electrons that are taken by copper. Is this clear what I am saying? If I am saying oxidation potential is more for an element, what does it mean? That fellow will be having more tendency to lose the electron, more tendency to undergo the oxidation. Okay, now I am saying an element is having more reduction potential. It means that fellow or that element has more ability to undergo reduction. It means reduction means by gaining of electrons. Is this clear what I am saying? Yeah. So here zinc is having more reduction. I will tell you more tendency to undergo oxidation. So now I will tell you about all that elements and how to remember them. I will tell you later. But out of these two, which reaction is possible? First one. So how to decide exactly? We have a table. I will tell you later. But just now you just remember that during this reaction we need to understand whether the given chemical reaction or redox reaction or not, and if it is a redox reaction whether it is a spontaneous one or non-spontaneous one. So now what is the use of identifying a spontaneous or a non-spontaneous? See, if a redox reaction is happening spontaneously, using this spontaneous redox reaction we can able to generate electricity. What we can do? That is what galvanic cell, Daniell cell you have studied. So there what we will be using? Zinc and copper only we are using. Okay, so there you are going to see some electrode potential generation of 1.1 volt energy is generated. By a spontaneous redox reaction, what happens? Electrical energy is generated. What I am saying? So that we will be linking to the electrochemistry. Okay, sir, this reaction is a not a spontaneous, it means we can call it as a non-spontaneous. So I want to do this reaction, sir, I want to extract zinc. You might be having like metallurgy you have studied somewhere, okay. So there like we need to extract mining of gold or something like that we will do now. So there actually a impure metal can be extracted out. With what method? See, if a reaction is happening spontaneously, it will generate electricity. How much energy it is generating? I am saying this reaction is not happening spontaneously. Now what I will do? I will apply energy greater than this. It means I am applying some 2 volts of energy to the reaction, to this reaction. Now this is not spontaneous reaction now. So when I apply this much amount of energy, what happens? Reaction goes in opposite direction. If I apply energy to this, reaction goes in opposite direction. It means this reaction is going to happen. A non-spontaneous reaction can be achieved by applying energy. A spontaneous reaction produces energy. A non-spontaneous reaction happens by applying the energy. Is this clear? Okay. Next. So now what are the ways we can define oxidation and reduction? See, first one, when I say word oxidation, what is that word? Oxidation. It means addition of oxygen is an oxidation, or removal of hydrogen is also considered as oxidation, or see, increment in the positive charge is also oxidation. What are the 3 formulas, 3 things I am saying? First one, addition of oxygen or removal of hydrogen. Okay, next one, removal of electrons also oxidation. So these are the 3 things you need to remember. What are the oxidation processes? Removal of hydrogen or removal of electrons. So removal of electrons is nothing but if you remove electron, if you are removing negative charge, what happens then? Positive charge on that species increases, right now. See, here plus 2 is converting into plus 3 means what I am doing? 1 electron is removed. So removal of electron is also oxidation. Is this clear up to here? 3 points. Okay. Next one. Removal reduction means what? Opposite of this. See, reduction means what I can say now? Addition of hydrogen or removal of oxygen or addition of electrons. So these 3 methods are called what? Reduction. Okay, is this clear? Okay. So now we are going to study about redox reactions. It means what? Both oxidation and reduction are involving in that reaction. Okay. See, during an oxidation what happens? Electrons will be oxidation. Electrons will be lost. Okay. During reduction electrons will be gained. Now what we are going to study? Redox reactions. It means the number of electrons lost in oxidation will be equals to the number of electrons gained in the reduction. So both should be equal in a redox reaction. Remember this point, very important. Now I am using a word oxidation number. What is that oxidation number means? See, once read that statement. It is an imaginary charge developed over the atom of an element when it goes from its elemental free state to combined state in a molecule. For example, see, I am giving you carbon dioxide. Like carbon dioxide means CO2 you are writing now. See, now I am asking you to find what is the oxidation state of carbon. What I am asking? What is the oxidation state of carbon? So how to do this? It is based on the assumption that a complete transfer of electrons takes place from a less electronegative atom to the more electronegative atom. So it means oxidation state is based on what? Electronegativity. Okay. See, who is more electronegative between these two atoms? So how many electrons are there here? One bond contains 2 electrons now. So all these electrons are taken towards more electronegative side. Okay. See, to this bond formation, carbon is providing 1 electron for one bond formation. Oxygen is also providing 1 electron. Similarly, this bond also. Similarly, this side also. Okay. So when I am shifting one bond to one side of the atom, so it should be -1 with respect to that bond. This is losing that bonded electrons now, +1. Like that, this bond also going this side means oxygen -1, this carbon +1. So this side also -1, +1. This side also -1, +1. So what is the net charge present on the carbon? +1, +1, +1, +1. How much? So carbon dioxide, the carbon oxidation state will be 4 and oxygen oxidation state will be -2 for each oxygen atom. Is this clear or not, everyone? Yeah. Like this, you need to calculate the oxidation states. Okay. So now what is the primary thing you need to remember? Electronegativity difference. More electronegative atom take the bonded electrons towards itself. Okay. Now in the periodic table, who is least electronegative group? Alkali metals. So whenever you see alkali metals in any compounds, always give alkali metals as +1 charge. How much charge? Next, after that, who we have? Second group, alkaline earth metals. Always give them +2 charge. How much? +2 charge. Okay. Now halogens are there means who is most electronegative in the periodic table? First most electronegative element is fluorine. Always give -1 charge to the fluorine if it is attached to the other elements. Okay. Who is the second most electronegative in the periodic table? Always give -2 charge to the oxygen if it is attached with the other element other than fluorine. Between fluorine and oxygen, who is electronegative? Fluorine. So fluorine should get -1. Oxygen should get no? +1 because fluorine is more electronegative. Now I will give example, no issues. Okay. Do it for this sulfur in sulfate ion fast you should do. These are very basic. We have lot of things to study. So sulfur means X. Okay, you need to calculate for sulfur now. Consider it as X plus oxygens are how many? 4. So each oxygen is divalent atom now. So overall charge -2. Okay, I hope everyone knows this how to calculate. +6. Okay, right. Next one. First we will do the questions here. Do this fast. Fast. Okay. All of those are, yes, tell me here first. Plus plus so remember here, whenever you are calculating oxidation state, oxidation number never, oxidation number never exceeds its maximum number of valence electrons count. For sulfur atom, what is the valence electrons we have? 16th group now, 6 valency electrons. 16th group now, so you will get 6 valency electrons. So sulfur oxidation state never be greater than 6. Okay, it should be always less than 6. But if you calculate how much you got? Plus 8. It means it is wrong. Okay, so why it is wrong? See, whenever there is, see here. Okay, before solving this, you just solve me one more question so that I can consider everyone knows how to calculate oxidation state. For manganese you find? Do it for here also, for chromium here. Fast. So here how to do? For manganese I am saying X. So here +1 for 1 potassium, and here 4 oxygens, each one -2, overall molecule is neutral, equals to 0. So X will be +7. So here it is 2X, here 2 potassiums are there, each one is +1, and 7 oxygens are there, each one is -2, equals to 0. X will be now +6. Okay, this is clear now everyone? Normal calculations, these are clear now, how to do oxidation state. So now whatever you are doing, these are called average oxidation state. What is this? Average oxidation state. Okay, now here whenever, if calculated oxidation number exceeds maximum oxidation number, then there exists a peroxy linkage, there exists peroxy bond. So what do we mean by peroxy bond? See, sulfur I am writing. You write how many bonds oxygen can make? It can make 2 bonds, 4 bonds, maximum 6 bonds. Okay, so now what I am writing here is OH, sulfur, 1 oxygen is over, second oxygen also over, okay, third one over. So 4, 5 means 2 more are there, and 1 oxygen, 1 hydrogen also there. So peroxy bond means like this. How I am writing? See, oxygen linkage is there, na? This is called what? Peroxy. Like you know hydrogen peroxide, na? H2O means you are writing like this. H2O2. Find the oxidation state of oxygen in water and H2O2. So here it will be -2 you will get, but here if you do, it will be -1 you will get. Okay, so what is the oxidation state of oxygen in peroxides? -1. So here also with respect to this bond, see, who is more electronegative between oxygen and hydrogen? So it should be -1, this should be +1. Between sulfur and oxygen? Oxygen -1, sulfur +1. Between oxygen and sulfur again? Oxygen, so 2 bonds means -2 here and +2 here. Similarly with respect to this bond, +1 for sulfur, -1 for oxygen. Between these 2 bonds, -2 here, +2 here. So add these numbers now. 2 plus 2, 4 plus 1, 5 plus 1, 6. So what is the oxidation state of this sulfur here? Plus 6. Don't say 7 from now onwards. Is this clear, everyone? So whenever you calculate the average or calculated oxidation state exceeds the maximum oxidation state, then there exists what? Peroxy bond. Okay, clear, everyone? Yeah. So now tell me for this one. This one. Plus 3 is incorrect. Do it and tell me fast. So how much you got if you calculate? Normally if you do, how much you got? Average oxidation state. 7, huh? Okay. See, it is like plus 2 plus 2x plus 8 into minus 2 equals to 0. So 2x will be 16 plus 2 minus 14. If you send this plus 14, so x will be how much? 7 plus 7. Is this possible? So this is not possible now. So it means there also exists one peroxy bond. So you put sulfur, sulfur here. Okay, give name, same number of oxygens and hydrogens. 1 oxygen, 2nd oxygen, 3rd, 4th, 5th, 6th. Like this I am writing. Now how many still oxygens we have? 2. Like this you put peroxy bond. So what is the oxidation state if you do? Calculate, plus 6 you will get, here also you will get plus 6. Clear, everyone? Clear or not? So first find normal like this average oxidation states. Okay, if it is exceeding the maximum oxidation state of the central atom, what you should consider? Peroxy bond is present. Now you might be having, sir, how many peroxy bonds we need to keep? See, how much you got here? Plus 7 now. How much number it is more? 1. Okay, so if it is 1, you just take 1 peroxy bond. It is not the case all the time. Okay, I will tell you how to identify that also. You do it for this chromium. How much? Plus 10 you will get. But chromium, how many valence electrons are there? Valence etla kanukuntam amma? Chromium valence electronic configuration, tell me. 3d5 4s1. So total valence electrons how many? 6. So chromium cannot show more than 6 oxidation state. Plus 6 oxidation state. It means our calculation is again. So here also you need to arrange that in the way that you will get plus 6 or less than that oxidation state. Okay. So if you calculate, you got 10. But I am saying it cannot be more than. Okay. So the calculated oxidation state, see here what I am doing. Calculated oxidation state minus maximum oxidation state by 2. Once again, calculated oxidation state minus maximum oxidation state by 2. So how much it is? 10 minus 6 by 2. 4 by 2. So how much we got? 2. So it means this compound contains 2 peroxy linkages. How many peroxy linkages? 2 peroxy. So try to insert 2 peroxy linkages in a possible way. Peroxy means definitely oxygen-oxygen bond should be there. Here also oxygen-oxygen bond should be there. Done. Next, can put like this. How it is? Like a butterfly. Okay, you can remember it as a blue butterfly. What is that? Why I am saying blue butterfly? Its color is blue. The compound color is what? You can remember it as blue butterfly. Okay. See now, same. This tricky formula. This is not all the time possible, but mostly it will work. This one, this calculated number of peroxy. Actually, you should need to remember the structures. But sometimes we may forget the structures. In that case, it will be helpful, this formula. So what is that number of peroxy linkage formula? Calculated oxidation state is 10 minus what is the maximum oxidation state of the central atom? So 10 minus 6 by 2. So 2 we got. That is the number of peroxy linkages. Now you do it here. Calculated oxidation state is how much we got? 7. What is the maximum oxidation state we will get? 6 by 2. How much we got now? 1 by 2. See, there is nothing like 1 by 2 bond now. Take it 1. Is this clear? What I am saying, is this clear or not? మనకి half bond అనేది ఉండదు కదా, so take it as a complete bond. So 1 peroxy bond will be there. That's it. Okay, next compound is bleaching powder. So bleaching powder formula is CaOCl2. Okay, see, if I want to explain this, you might be think like this, calcium oxide dot Cl2. So you may think that calcium is +2, oxygen is -2, like this you may write. But here the story is different. So calcium will be always +2 only. So now here oxygen, chlorine, chlorine. So out of these 2 chlorines, 1 chlorine will be with -1 charge. Okay, see calcium how much charge ma? +2. So this is +2 means already 1 chlorine is -1 charge. Okay, between chlorine and oxygen who is electronegative? Oxygen is second most electronegative, first is fluorine. So definitely this is -1 here. Between these 2 bonds you tell me now. Oxygen is more electronegative now, so this will be -1, this will be +1. So here in this calcium +2, oxygen -2, 1 chlorine +1 and another chlorine -1. So these are the individual oxidation state you need to remember for bleaching powder. What is the formula of bleaching powder? CaOCl2. And what are the oxidation states of chlorines there? +1 and -1. Fine. Done? Find this question on. Okay, so do it for this first question. Fast. Find for potassium as well as oxygen. Read the question now once. Potassium, what they are asking? Potassium how much in the combined states? Read the question once again. Once again read the question. Oxidation number of potassium. See, whenever alkali metals, when they combine with other species, always alkali metals will be, what is the answer then? You are always in the eager to calculate for the oxygen atoms, I think so. So now tell me once again, for potassium it will be always, sodium also +1, like that for all alkali metals. Okay, now tell me for oxygen atoms. If potassium is +1, how many potassiums are there? So it is +2. Oxygen will be? Do it in the same way for this. Minus? This is -2, this is -1, this is -half for each oxygen atom. Is this clear or not? See, potassium is +1. So O2 should overall should contain as -1. So for 2 oxygen atoms -1. For 1 oxygen atom 1/2, -1/2. So like that you can write. Okay. So they are asking for potassium means what is your answer? Fourth option. Next. Do this fast. Who is electronegative here? So oxygen should get negative charge, nitrogen should get positive. Yeah, tell me now. Which option? So how much here? NO plus 2, and for here, for this one, that's it. Match them there. Okay. So NO3 minus NO2, NO, N2O. So you just do for this one. Fast. Yes. Tell me here, what is the oxidation state? Change in oxidation state is 5, they are saying. Yeah, you tell me from where we have oxidation state change is 5. Fast. See, what is the oxidation state you got in the first option? Here. C2O4 2 minus is there now. So this is called oxalate ion. What is that? Oxalate ion. You know oxalic acid? Oxalic acid. H2C2O4 is called oxalic acid. If I remove 2 protons, it is oxalate ion. Now here charge is plus 3, converting into CO2. So what is the charge here? Plus 4. So from here to here, what is the change? Oxidation number change is 1. Okay, we will come back to this. Wait for some time. Next, here what is the oxidation state for manganese? Plus 7, converting into plus 2. So change is how much? 5. Now for this question, you tell me option C. 6 is converting into 3. For this one, if you calculate, you will get 6. 6 is converting into 3. This is fine now. Okay, what is our answer? For this question, discussion is over. Now next thing I wanted to explain here itself is, see, manganate, permanganate ion converting into Mn plus 2. Like this now. From where to where? Plus 7 to plus 2. So tell me whether this is electron gain or electron lost? Gain. Reduction process. So how many electrons it is gained? 5. So during an oxidation or a reduction, the number of electrons gained or lost will be there now. That is called its N factor. What is this? N factor. So what is the N factor for this manganese here? 5. I am not asking about oxidation states. What I am asking, number of electrons gained or lost during a reaction. Okay, how many electrons it is gained? 5. Now in the first case, like C2O4 2 minus converting into CO2, right now. So here what is the charge oxidation state you told? 3. Here it is 4. Now how many electrons gained? 1 you are seeing. Actually you are seeing it as 1. But what is this number? 2. For 1 carbon, 1 electron. How many carbons are there? 2 carbons. So 1 into 2. So total 2 electrons. What is the N factor I should say during this process? 2. Is this clear? Okay. Okay. We will come back to this later again after some time. So now, when you are finding oxidation state, the maximum oxidation state of an element equals to the maximum number of valency electrons in that element. That is electrons in the valency shell. Okay, carbon valency, how many electrons are there? 4. So its maximum oxidation state will be Nitrogen, how many valence electrons are there? 5 valence electrons are there. So maximum oxidation state is +5. Okay. Now when it comes to minimum oxidation state, okay, so electrons in a valency shell -3. It means carbon, how many valence electrons you told you previously? 4. -8. So 4 minus 8 means -4. So what is the minimum oxidation state of carbon? -4. In the same way, you tell me what is the minimum and maximum oxidation state for nitrogen? +5 is the maximum. How -3? 5 valence electrons, 5 minus 8. -3. Is this clear? Okay. Are? Next. Okay. See, you just find the oxidation state of central atom first in a given compound. For example, I am giving you KMnO4. KMnO4 I am giving you. Find the oxidation state of central atom like this. Okay. Once after finding the oxidation state, if the oxidation state of that central atom is the maximum oxidation state for that element, what is the maximum oxidation state possible for manganese? +7, because D5S2, 3D5, 4S2. So 7 valence electrons are there, so +7 is the maximum oxidation state possible. So if the oxidation state of that element is equals to its maximum oxidation state, that act only as an oxidizing agent. How it will act? What do we mean by oxidizing agent? Which undergo reduction and oxidizes. Once again, Mn +7 is there, ma. Already it is in maximum oxidation state now. Is it possible to oxidize it further to Mn +8 or +9? So it will not undergo oxidation further. An oxidizing agent will undergo reduction and oxidizes others. Once again, oxidizing agent undergo reduction, oxidizes others. Like travel agent means travel agent won't travel. He will make other to travel. Yes or no? Similarly, oxidizing agent means it will not undergo oxidation. It will make others to undergo and itself undergoes. Is this clear, everyone? Yeah. So if a species is in its maximum oxidation state, act only as oxidizing agent. If a species is in its minimum oxidation state, act only as reducing agent. Okay. So remember this, maximum oxidation state act as, minimum oxidation state act as, if it has intermediate oxidation state, then it has both possibilities to act as oxidizing agent also as reducing agent. So what I told you, maximum oxidizing agent only, minimum reducing agent only. Okay. If oxidation state is intermediate between maximum and minimum, it can both act as oxidizing as well as reduction. What it can do? Both it we can do, oxidation as well as, yeah, that's it. Now I am asking you one question, simple question. You tell me here, H2S, K2, Cr2, O7 I am writing. So tell me whether, what is the nature of this H2S, whether it act as oxidizing agent, reducing agent or both? H2S. See, what is the oxidation state of sulfur here? Here in H2S. What is the oxidation state of sulfur here? Minus. If it is -2, so for 16th group element, what is the minimum oxidation state possible? Minimum -2. See, already it is in minimum oxidation state now, so it will not undergo reduction further. So it will undergo oxidation, reduces others. So I can say this is a so that is what? If oxidation state is equals to minimum oxidation state, it can act as a so H2S can only act as reducing agent. Now tell me for this potassium dichromate plus 6 now. Plus 6 means what it can do now? What for chromium, what is the maximum oxidation state possible? 6 only. So now it can act as only as oxidizing agent only. Okay, is this clear? Okay. So there are some examples for oxidizing agents, you can check here. Oxidizing agents are those compounds which can oxidize others and reduces themselves during a chemical reaction. Okay. Now here the best example is KMnO4, K2Cr2O7, nitric acid, sulfuric acid and fluorine are some examples for what? Oxidizing agents. Okay. Now remember here KMnO4 I am saying now. So KMnO4, what is the oxidation state of manganese? Plus 7. So now it will always act as what? Oxidizing agent only. What it will do always? So if I do the chemical reaction in acidic medium, KMnO4 from plus 7 converts to plus 2. From where to where? Plus 7 to so I can perform the reaction in neutral medium also sometimes, or slightly alkaline medium, neutral medium or slightly basic medium or alkaline medium I can say. Okay. So here it will converts into Mn plus 4. What is that? Mn plus 4. Mn plus 7 in strong alkaline medium or strong basic medium converts from plus 7 to plus 6. Remember these numbers. Okay. So now what they will ask you is, what is the N factor when permanganate ion reaction in acidic medium? So how many plus 7 is converting to plus 2 now? How many electrons involved? So N factor is 5. Here plus 7 is converting into plus 4 now. N factor is 3. Is this clear what I am doing? Okay. This one? So N factor is 1. Remember. Okay. Up to here it is clear. So when I am discussing about like in the first chapter, I told you something like molecular weight or molar mass and also equivalent mass or equivalent weight. What is the relation between equivalent weight and molecular weight? Equivalent weight equals to molecular weight divided by N factor. Okay. Now the simple question, they will give you a compound like KMnO4, they will mention what is the equivalent weight of KMnO4 in acidic medium, they will ask. What to do? Its molecular weight divided by N factor. 5 in acidic medium, 3 in basic medium, 3 in alkaline what is this? Slightly basic medium and 1 in strong basic medium. Is this clear or not what I am saying? Yeah, that's it. So write this table. Okay. Over. Just write this one. Do it fast. Okay, after this, so there is something called disproportionation reaction. What is it? Disproportion reaction. What do we mean by disproportionation reaction? Same element undergoes both oxidation and see here, if I say hydrogen peroxide, what is the oxidation state of oxygen here? -1. So converting to H2O plus O2. What is the oxidation state here? Okay. What is the oxidation state? Okay. So what is the oxidation state of oxygen here? -2. Here 0. So -1 to -2. What is this? Reduction. From here to here, oxidation. So the same element undergoing both oxidation as well as reduction. Now this type of reactions are called what? Disproportionation reactions. Okay. Now there are some disproportionation reactions that you need to remember. See, the first reaction we have studied just now. See, you know halogens now, like chlorine, bromine, iodine, like that we have. Okay. So you can take chlorine or bromine. What I am saying, you can take chlorine or bromine, not fluorine. Okay. X2 can be chlorine or bromine, not fluorine. So if you treat that with a dilute OH minus, like dilute base, it will convert into X minus and OX minus. So now what is the oxidation state here for a halogen? -1, and here it will be +1. Okay. So if you do the same reaction X2 with OH minus, but here it is concentration. So now the further oxidation takes place. Here -1 same, but here it is +1, here it is +5. Okay. When it is +5, when you are taking concentrated acid. Okay. So X2 can be chlorine, bromine, iodine, but not fluorine. So why not fluorine? Because we know fluorine is the most electronegative element now. So it will not get oxidizes as undergoes oxidation like this. So it will be having some other type of reaction. See. So F2 with NaOH, like dilute base, gives F minus as like X minus here, but here it is OF2. OF2 means what is the oxidation state of oxygen and fluorines here? OF2 means fluorine is more electronegative now, so that is also minus only. Oxygen will be with a +2 charge because 2 fluorines, 2 minus, oxygen will be 2 plus. Okay. Next one, F2 plus NaOH concentrated. So it will be F minus plus O2. O2 means what is the oxidation state of each oxygen? When an element combined with itself, oxidation state will be 0. So O2 oxidation state here is 0. So dilute means like this, you remember, concentrated means like this. Okay. So they will ask you X2 in dilute base, what are the products formed? Like chlorine in dilute NaOH, chloride ion plus chloride, chloride ion plus OCl minus, OCl minus, OCl minus, instead of giving like this, they may give like this, HOCl. HOCl is nothing but just I added proton from water. So this is called hypochlorous acid. What is that? Hypochlorous acid. Okay, that's it. Okay, remaining reactions also in the same way. Next, comproportionation reaction means what? See, it is like reverse of disproportionation. Disproportionation, what happened? Same element undergone oxidation and here same element only, but with 2 different oxidation state gives you the single oxidation state. It means what is this final oxidation state here? It is 0 now. This 0 is coming from this -3 and from this +3. See, 2 different oxidation states of an element finally giving you the single oxidation state. Then these reactions are called what? Comproportionation. See, previously disproportionation means what? Same oxidation state containing element will undergo oxidation and also will undergo reduction. Now it is opposite of that now. So opposite means what you can say? Comproportionation. Previously it is disproportionation, here it is comproportionation. Okay. Next one is balancing of redox reactions. What is the next one? Balancing of redox reaction. See, generally you will be seeing questions like this in the exam. Even it is important for your IP exam also, 4 marks question now. Yes, okay. So now tell me how to balance this. I will tell you, no issues. See, what is the reaction they have mentioned? MnO4 minus plus C2O4 2 minus plus H plus giving you CO, Mn plus 2 CO2 H2. So first write that skeletal equation that they have given. Okay, after writing, assign their oxidation states fast. Here it is plus 7. Oxalate ion you just did previously. Plus 3. Here it is plus 2 already, and here it is plus 4. Done. Now like identify oxidation and reduction of reactions. See this species, what is happening to manganese? Reduction. What happening to this carbon? Oxidation. Now in reduction, how many electrons are involving? Plus 7 to plus 2 means how many electrons? 5 electrons. In oxidation, how many electrons involving? 1 electron. See, at the beginning of our discussion, I told you, during a redox reaction, number of electrons lost in oxidation equals to number of electrons gained in the reduction. Yes or no? But is these numbers equal? Now what to do? We need to equalize them. So how can I equalize them? See, here it is only 1. See, for 1 carbon it is 1. But how many carbons are there? So 1 into 2 means here 2 electrons. Here how many electrons? 7 is converting into plus 2. Means how many electrons? Is this clear up to here? First skeletal equation rayalamma. Next oxidation states ivalamma. Ichin tarvata which is undergoing oxidation, which is undergoing done. After writing like this, అర్థమైందా ఇక్కడ ఎన్ని ఎలక్ట్రాన్స్ వచ్చినాయి? అక్కడ ఈ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ని ఈక్వల్ చేయాలి. రిడక్షన్ నెంబర్ ఈక్వల్స్ టు ఆక్సిడేషన్ నెంబర్ అని చెప్పాలి. దానికి నేను ఏం చేస్తున్నానంటే, వాట్ ఈస్ ద నెంబర్ హియర్ ఐ హ్యావ్? సో ఐ కెన్ మల్టిప్లై దిస్ ఈక్వేషన్ విత్ 2. వాట్ ఈస్ ద నెంబర్ హియర్ ఐ హ్యావ్? సో ఐ ఎమ్ మల్టిప్లైయింగ్ దిస్ 5. సో హౌ మెనీ ఎలక్ట్రాన్స్ ఇట్ బికమ్? So how many electrons it also become? So electrons are balanced in the, yeah. So you are multiplying this manganate equation with what? 2. So it becomes 2 MnO2, MnO4 minus 2 Mn plus 2. After doing this equation with which number? 5. So plus 5 C2O4 2 minus this side 5 CO2. Is this clear up to here everyone? Is this clear or not? Okay. If not, again I will explain, but let us finish this first. Okay. So now what are the other parts we have, other things they have included? That you just write them as it is. Don't disturb them. Okay. Up to here, how many now over electrons balanced? How many manganese atoms this side? Here also manganese is balanced. Carbons are how many? 5 twos are here only. So I just want to make the same number. So what I should do? I can erase this 5 and write 10. Is this clear? Next, how many oxygens are there this side? 8 plus 5 fours are, so 28 na total. 28 oxygen atoms this side. This side how many are there? 20. So 20 are there now. So what? How many are there now? 20. So wherever oxygens are less, that side you add water molecules. Previously you have one water molecule. Okay, I am writing 21. How many water oxygens are less now? So which side it is less? Wherever it is less, that side you add water molecules. How many less? 7. So I should add 7. That's 7 and this one. Total 8. So I can make it as 8 H2O. Is this clear what I am making? So oxygens are also balanced. Next, what to balance? Hydrogen. How many hydrogens there that side? 16. This side? Only 1. How many are less? 16. So 1 plus 15. Total how many? So you can add 16H plus. Is this clear or not what we are making? See, during the question, they may give like this, A, B, C. Just remove that ABCs, write the skeletal equation only. Balance it like this. Then compare. A means how much? 2. B means how much? 5. C means, like that you need to do in the exam. Okay. So now again tell me from the basic step 1 onwards. Like it should be on your fingertips now. What is the first step? Write the skeletal equation. Then next, assign the oxidation numbers. Next, identify oxidation number, oxidation reaction and reduction half reaction. Don't write separately, just make it here itself. Identify oxidation half and after doing that, identify number of electrons lost in oxidation and number of electrons gained in reduction. Okay, now we need to equalize that electrons. How many electrons here? 2, here it is 5. So it is easy to multiply with the crisscross method, like here it is 5, here it is 2, then 10 it becomes. Done with this. Now balance the elements. Manganese atoms 1 here, there should also like 2 here, here also it should be 2. Carbon atoms 10 here, there also it should be 10. First balance all atoms other than oxygen and hydrogens. Carbon and ammonia only we have. What is this? Manganese only we have, that is done. Next, who is there? Oxygen and hydrogen. Now balance oxygens first, at last for balancing oxygens what to do? Where to add? Wherever it is deficient, you add there. What to add? Water molecule. Now how to balance hydrogens? Adding of H plus. Where to add? No, that's it. Now what is your answer finally? Check this. 2, 5, 16. That's it. Okay, just identify this thing. Do it fast. Yes, tell me. See, plus 1 is converting into plus 2 and 0. So what is this? Once again define disproportionation means? Going now? Yeah. This one? What is oxidation state? A. MnO4 means don't say plus 7. Do it properly. It is minus 2 now. So if you calculate here, you will get plus 6. Okay, so here it is plus 4, here it is plus 7. See, minus 1 charge is there means plus 7. So what is this reaction now? 6 is converting into 7, oxidation, 4 means reduction. So this is also disproportionate. What about this? See, what is the oxidation state? Plus 7. See, manganese can show maximum of plus 7 only. Further oxidation possible. If it is not possible, then this species will not undergo disproportionation reaction. So remove it. Next, here also same story. So only A and B, first option. Clear or not, everyone? Identify this, very basic. Fast. Which reaction is not a redox reaction? So redox reaction means what to there? The two parts are there or not, you check. Fourth. Which is not a redox reaction? No. Tell me what is your answer? First one you check their oxidation state. What is oxidation state here? I told you one statement. Whenever alkali metals or alkaline earth metals are in the combined state, they are always in plus 1 for alkali metals, plus 2. So here plus 2, here also. Here, so here it is minus 1. Here also it is minus 1. This one here plus 1, here also plus 1. Here sulfate ion, here also sulfate ion means plus 6 here, here also plus 6. Is there any involvement of oxidation reduction? No. So only first option is not a redox reaction. What about this one? 0. This one plus 2. Redox. This one you tell me. This 2. So you are not giving work to your pen now. Converting from plus 1, so it is also redox reaction. So 1 is not a redox reaction, but 2, 3, 4 are what? So what is your answer? First option. Okay. Okay, up to here your redox reaction part is almost done. Slowly we are entering to the electrochemistry now. See, at the beginning, at the first slide itself, I have written 2 reactions and I asked you which reaction is possible, which is not possible or not feasible, I told you. Okay, so that you can answer from this table. See, are you able to see it? Now? Okay, see here, lithium plus, what is this? Lithium plus converting into lithium atom. So what is this process called? Oxidation or reduction? Sodium plus converting into sodium. Magnesium plus to converting into magnesium. Aluminium plus to converting into aluminium. By gaining of what? Okay, so all these are reduction potential values. What is that? Reduction potential. So if you observe the reduction potential values like minus 305, minus 2.93, like that we have. So which is having more value here? Out of this, see, more negative value means like least energy right now. Okay, so means what you need to understand here is, if a species is having more tendency to undergo reduction, its value should be high. What I am saying, if a species is having more tendency to undergo reduction, its value should be high. So now tell me, out of this aluminium to lithium, who can easily undergo reduction? Relatively lithium only, relatively aluminium only. More value this one only, na, like this. So highest value if you observe in the table, in this table, from who, for who you are seeing in this table, highest value is for AgCl. Like that, the complete table contains this many elements. So the highest reduction potential value is for whom? Fluorine. How much it is? Plus 2.87. So the strong, the species which has more tendency to undergo reduction is who in the complete table? Fluorine. So it is having more tendency to undergo, F2 is having more tendency to undergo what? It is undergoing reduction means the species which reacting with this fellow will become oxidized. So I can say F2 is a strong oxidizing agent. What is this? Strong oxidizing. Who is strong oxidizing agent in the periodic table? They will ask you. Fluorine. Okay. Now in this table, who is at the bottom? Lithium. So lithium will be strongest reducing agent. Strongest oxidizing agent is here fluorine. Strongest reducing agent is lithium. Remember this. So now metals are strong reducing agents, I can say. What I am saying? Metals act as, like alkali metals act as strong reducing agents, and halogens act as a strong oxidizing agent. So highest oxidizing agent is fluorine, and highest reducing agent is lithium. Okay. Okay. Now I'm writing two lines here. Just take. So these values are reduction potentials or oxidation potentials? Huh. The more reduction potential more tendency to undergo reduction. What I am saying? More reduction potential value, it has more tendency to undergo reduction. So example, fluorine F2 converting into F minus. So its E0 potential is how much? Plus 2.87. Okay, and here next one. I'll take one more example for comparison purpose. F2.87, and the next chlorine is 1.36. So out of this you might get here the more reduction potential value for whom? Fluorine. So it can act, it can have more tendency to undergo reduction. Okay. So now out of these two, who is a strong oxidizing agent I am asking? Huh. Okay. The more positive reduction potential value, stronger oxidizing power, more oxidizing power, strong oxidizing agent. So what I am saying here, once read these lines. More positive oxidation, more positive reduction potential value, more positive reduction potential value, more oxidizing power. Who is more oxidizing, like who is having more oxidizing power, they will ask you. More oxidation, more reduction potential, it will be act as strong oxidizing agent, or it has more oxidizing power. Remember these statements. Okay. See, E0 oxidation will be equals to E minus of E0 reduction. It means what? See here, what I am saying, E0 oxidation equals to minus of E0 reduction. What does it mean? See, F2 converting into F minus. This is oxidation or reduction? This is oxidation or reduction? 0 converting into minus 1 means reduction. So reduction potential, E0 reduction is how much they have mentioned? Plus 2.87. 2.87. Okay, if I write opposite of this, F minus to F2, it will become how much? This is oxidation or reduction? So it should be called as E naught oxidation. So it should be opposite of this value, like minus 2.87. So you can remember that E naught oxidation and E naught reduction will be having same magnitude with opposite sign. Okay, that's it. Remember up to here. Next. So now what I told you, more reduction potential, more tendency to undergo reduction. That act as a strong oxidizing agent. Okay. So now who is having least reduction potential in the table? Lithium. So what is its value here you have seen? Minus 3.05. So can I say more negative reduction potential or more positive oxidation potential? Is these two lines the same or different ones? Read it them. More negative reduction potential, more positive, can I say like that? Is for whom? Lithium. Act as strong reducing agent. Reducing agent. Chestanu. So I am writing this as lithium plus converting into lithium minus 3.05, K plus converting into K minus 2.93. So now tell me who is having more negative reduction potential? Lithium. More negative reduction potential, I can also say more positive oxidation potential. So which species will undergo oxidation easily? The one which is having more positive oxidation potential. See, more negative, or I can say more positive oxidation potential. So lithium undergo oxidation easily and reduces others. So I can say which is act as strong reducing agent out of these two? Lithium. So lithium act as strong reducing agent. Okay, remember these lines. Okay, but when it comes to exam point of view, they will give you the values like this. Okay, anyways, I will show you one. First read these lines, first you understand this over this one, these lines that we have written. Finish them. If you finish this, we will do some questions, then you will get more clarity on this. Done? Look at this. Read the question once. Which of the following is strongest? Tell me. Strongest oxidizing agent means it should have tendency to undergo reduction. Okay. So which is having more reduction potential here? See, ఇక్కడ చూడాలమ్మా ఫస్ట్ వారు ఆక్సిడేషన్ పొటెన్షియల్ ఇచ్చారా రిడక్షన్ పొటెన్షియల్ అనేది +5 is converting into -1. What is this process? +3 converting into +2, +7 converting into +2, +6 converting into +3. So reduction potentials are given. So by looking at the reduction potential value, more reduction potential value, that species act as strongest oxidizing agent. So who is strongest oxidizing agent out of 4 options? This one, third option. So if I ask for the order, first one is 3, 3 1 3 1 1.5 no 3 1 4 2. Is this clear or not? How we are answering the questions? Okay. Next. So more oxidation potential, more reduction potential means act as a strong oxidizing agent. Right? Okay. So now every time remembering this complete series is difficult. Remembering this complete series is difficult. So let me give you one simple way to remember all those elements. See, who can act as strong reducing agents, tell me? It means alkali metals. Okay, particularly lithium we have first. Okay, so what I am writing? You can also write. Okay. See, what you will do is you read it fast, like lik ba sar kha na ma, like that. You just read it fast. It is chapa only. Okay. See, don't read outside, at least inside of you. Okay. So you will get one flow. Okay. So who is strongest reducing agent? Okay. So now here I have written like this now. So this is copper. This is mercury, this is silver, this is platinum, and last one is gold. See, just remember Hg, Ag comes side to side like that. Okay, what is a way to remember them in the simplest way? Like a wrap. Okay, next. Next one, this is about cations. What is this? Okay. What are the charges? You write their charges. You write their charges also. So now the metal ion or the cation which is at the right side will deposit first during electrolysis. So which metal ion or which cation will deposit first during electrolysis? The one which is at right side. Right side, who is at the right side? Topmost right. Go here. No. Continuation this one also. There we do not have space now. So who is at the right side? This chapa metals. Okay. So chapa metals means what? This one is gold here. Copper, silver, mercury, silver, platinum, Rm. So Rm will deposit first during our electrolysis process. Okay. So once read them again and again in your yourself. Okay, anions. Sulfate ion, nitrate ion, fluoride ion, So what about anions? Who will deposit again during the electrolysis? One which is at the right side. So which anion will deposit first? Iodide ion when we are doing electrolysis. I will tell you about electrolysis process, but you just remember them. Okay, right. See, it is easy, ma. First, if you observe, we have alkali metals. What are these two things? Alkali metals, and these are alkaline earth metals. See, alkaline earth metals, but at the bottom we have like barium, strontium. At the bottom, na more metallic character. So they came first here. After that, sodium here we have. Okay. Next, magnesium. First group, second group is done. Next, aluminium. This side, 13th group. Next, manganese, transition element. Next, zinc, cobalt, iron, chromium, nickel, tin, lead, H, chapa. Okay. So now, what do we know from this means? These metals are there now, like this side metals. Listen, this side metals are there now. Whatever the metals you are seeing this side. So if I have that metals, like these metals definitely in the positive charge. Okay, I have that metal like aqueous solutions. What I am saying? Metal aqueous solutions. So along with that metal aqueous solutions means what are the cations we should have now? That metal ion will be there. Along with that aqueous means H plus ion also will be there. So if I am doing electrolysis, the metal ions from here to here, whatever it is present, during that case only H plus ion will deposit as H2 gas. Who will come out as a thing? H2 gas. It means metal ion remains as like that, but who will come out here as a product? H2. If we have these ions, these cations along with our H plus, during electrolysis who will come out now? This side. If I say before this left side, if these ions are present, H2 comes out. This right side are there now after this H, this chapa metals. So these metals comes out instead of H2 gas. Once again, these metal ions are there in our aqueous solution. So what will deposit? Hydrogen gas will liberate. Okay. So along with our H plus ion, if these metal ions are there, this one after the H plus ion, these chapa metals are there, chapa metals will deposit first. Within these chapa metals, who will deposit first? Rm. Is this clear what I am saying? Yeah. Okay. Next one, I think you are much familiar with this galvanic cell. So let us discuss about this galvanic cell before solving some questions. So what is the use of galvanic cell? So there are two types of cells, electrochemical cells and electrolytic cell. So electrochemical cells converts chemical energy to electrical energy. So Daniell cell or a galvanic cell is one of the example for electrochemical cell. So with the help of a chemical reaction, what happens? With the help of a chemical reaction, electrical energy is produced. So now for this we need to have what? Two containers. This first one is filled with what? Zinc sulfate solution in which zinc rod is dipped. Okay. In this copper sulfate solution, copper rod is dipped. Okay. Okay. Now for the connection of these two things, what we need to use? Like a U-shaped salt bridge, like this, right now. So in this we are using some agar-agar gel. See, what do we mean by this? It is something like there is no ions in that. It's like a jelly substance. Might be something like some powder. Okay. So that will be mixed with some electrolytic solutions, like inert electrolytic solutions like KCl or KNO3 or what? Ammonium nitrate, NH4NO3. Sir, why we are specifically using these solutions only? Because see, if you observe, there is one K plus ion and one Cl minus. The transport number, the mobility of cation, anion should be equal. Only that kind of substance will be used in the salt bridge. What I am saying? The electrolytes which have same mobility for cation, anion will be used in the salt bridge. So now what is the use of salt bridge? See here, this rod is zinc we are discussing and this is copper here. Okay. So now this compartment is considered to be anode. So in anode compartment what happens? Always remember, anode means oxidation. What happens? Anode means oxidation. So here zinc metal is then a zinc rod will undergo oxidation, gives you zinc Zn plus 2 plus 2 electrons. So now these 2 electrons come from here like this, like this. What is flowing this side? Electrons. So electrons are coming here. Okay. Now here we have copper and copper plus 2 now. Copper plus 2 sulfate ions are there. So that will take these 2 electrons and will deposit as copper. Okay. If I am not using this salt bridge, what happens? All the copper plus 2 ions from the sulfate ion converting into copper atoms. Yes or no? Now what is remaining here? Sulfate ions are remaining as like that. So what is the charge on sulfate ions? So this is minus. Electrons are also minus charge. Will these electrons will be allowed if I have more number of sulfate ions? It will not be allowed, no? That's why we are using this salt bridge, so that the K plus ions from here comes and pair up with this, and that will neutralize this. That allows the passage of electrons. Like this we are completing the circuit. So what is the use of salt bridge? To complete the circuit, cell circuit, and also to maintain the electrical neutrality. What is it? Electrical neutrality. Okay. So now here also what is the ions formed? Zn plus 2. So these Zn plus 2 ions also balanced by anions of this electrolytes that we are taking. Okay. Next one. So during this cell, energy is produced, we are saying now. So how much energy is produced? So at cathode what happens here? Reduction. How you can write? See, copper plus 2 ion plus 2 electrons converting into Cu. So what is the cell total net reaction you are seeing? Zn. What happened to zinc? Converts into Zn plus 2, and copper plus 2 converted into copper. So now cell reaction should be written first anode, then next cathode. So Zn plus 2, next copper plus 2, copper. So between them we are using salt bridge now, indicated with double slash. Okay. So first anode half cell, cathode half cell, in between salt bridge. See, sir, what is the use of indicating this slash? See, zinc is a solid now, but Zn plus 2 aqueous. Here copper is aqueous, copper solid means there is a phase difference now, like solid, aqueous. So phase difference should be indicated with this, separated with a single slash. That way we are using that. Okay. So first anode, salt bridge, next cathode. The next one here is, if you observe this, all Zn plus 2 ions are Zn is converting into Zn plus 2. Now what about the weight of this rod during the reaction? Decreases or increases? Decreases. Do you got what I am saying? Weight means, previously manaku zinc rod undi. A rod kaasta ela maarutundi, ions laga maarutundi ga. So weight of this zinc rod will be, weight of this copper rod will be, why it is increasing? Because copper plus 2 ions are converting into copper metal. That will deposit here. Like that its weight might be increased. Okay. Now what is the net potential generated during the cell reaction? E naught cell is equals to, see, E naught oxidation potential, you should say E naught reduction potential. This is the actual way of writing the formula, but it will be modified later. See, oxidation, where oxidation happening? Here. So what is that? E naught Zn converting into Zn plus 2 plus E naught copper plus 2 converting into copper. Okay. Now these values they will give you in the exam like this, or you should remember for some elements. See, Zn That big table is there now. From the table I am writing this. Zn plus 2 converting into Zn. This is minus 0.76 volt. And copper plus 2 converting into copper. This is plus 0.34 volt. Okay. So tell me first of all, these are reduction potentials or oxidation potentials? Zn plus 2 to Zn means what is this? Cu plus 2 to Cu means? So both of them are reduction potentials, but what I required here? Oxidation. So what I told you, oxidation potential and reduction potential opposite. Just remove that sign. So I should write here as plus 0.76 this one oxidation or reduction. So whatever the value they have given, right here. Add them total. How much? 1.11 volt. E0 cell you should make like this. Okay, is this clear everyone? Okay, so what is the formula to use? E0, E cell equals to E0 oxidation plus E0 reduction. See, they will be giving you a question like this in the exam. And they will be asking you to calculate EMF of the cell. How can you do this, tell me? E0 of the cell they will be asking you. How to do this, tell me? So which is like one species should undergo oxidation, other will undergo reduction. But you need to identify which will undergo reduction and which will undergo oxidation. See, who is having, see both of them are what here? So which is having more reduction potential? This one is more reduction potential now, so it will undergo reduction. So reduction takes place at which half cell? Cathode or anode? Cathode. So this reaction takes place in cathode. See, this value is less now, it means this will be happening in anode, and this is oxidation. Here it should be reversed. So this should be oxidation. It should undergo oxidation. So now what I should say? E0 cell equals to E0 oxidation potential plus E0 reduction potential. Okay. So E0 oxidation potential, did they give an oxidation potential here? Both of them are reduction potential. So first in cathode reduction, where is the cathode here? This one now. So you take this as 0.80, and oxidation potential how much I should take? This is reduction potential or oxidation potential? But what I should, okay, both of them are what? Okay, both of them are oxidation, but reduction potentials are given. Perfect. See, they are mentioned this as what, ma? Reduction potential. Say less reduction potential means where I should consider? Anode cell. So anode cell you take it as positive 0.13. So just add them. 0.93. So this will be your answer. See, once again I am saying E0 cell means, what is the formula? E0 of reduction, E0 of oxidation at where it will take oxidation? Anode, plus E0 of reduction, this is at cathode. Okay. So now, but the question given like this, what is the question given there? Both of them are given as reduction potentials only. So which half cell is considered to be reduction half cell? It means cathode half cell. Which is considered to be anode half cell? How to decide? More reduction potential will participate in reduction. So who is more reduction potential out of these? So this reaction takes place at a cathode, that is reduction taking place. Okay. Now the remaining reaction should happen at anode. So at anode what happens? Oxidation. So this is reduction potential means oxidation potential should be how much? Opposite of this. That's it now. So put that values over here. Next, add them 0.93 volt. Okay. So this is how you need to calculate. Okay. So in some books the formula will not be like this. Some books formula will not be like this. I will give you that formula also. See, this is reduction potential only now. I am writing as it is. At what? Cathode. This is oxidation potential. What I told you, E naught oxidation is equals to minus of E naught reduction. So this value also I am writing in terms of reduction. So minus E naught reduction. This is at anode. So E naught reduction at cathode minus E naught reduction at anode. So if you use this formula also, you will get the same answer. Cathode దగ్గర ఏ రియాక్షన్ జరుగుతుంది? Out of these two, this one or that one? More reduction potential is there now, that you take 0.80. Anode దగ్గర minus 0.13. So see, minus of minus, so same answer you will get. 0.80 plus 0.13. How much? 0.93. So any way you do, you will get the same answer. Either you convert this one value into oxidation potential and substitute in the main formula, or you directly convert your final equation like E naught cell equals to E naught reduction at cathode minus E naught reduction at anode, and you substitute the values given as it is. Then you will get the answers. Okay. So anyways, you will do one or two questions, then it will be more clear. We have written some metals which are the following. I mean, that I told now, that rap sang something. Use that and identify which reaction is not possible. Switch on that AC, anyone? Yeah, tell me. Which of the following reaction is not possible? So how can you identify? So not possible means what? See, I told you there are some metals this side in between H and metals this side. Okay, the metals which are this side can displace as hydrogen as H2, H plus as H2. But if they are this side, they won't displace H plus, they only deposit as their respective metal. Okay, so now see, here copper is there ma. Copper, which side it will be? Right side. So right side means what happens? Yeah. So this side, whatever the metal is there, they won't deposit H2, they will only deposit as metal. So they plus 2 charge is there, they will only deposit as metal. So it is possible. Okay, like that, Fe is there. So is there any charge on it? Yeah, 1 minute. Copper metals, you know now, what are those? Cu. Okay, so which metal will come out first? Like their charges should be there. So here you compare between these two. 0 plus 1. So the one which is at that side will come out first. So out of these two, who is at that side? Ag. So it means Ag will come out as, Ag plus will come out as Ag. So it means this reaction is possible or not? Yes. Like that, you need to compare the other reactions also. So here Br minus is there. Like anions, you tell me anion story. What are those ions I have written? Sulfate ion, nitrate ion, fluoride, chloride, bromide, iodide. So it means the one which is at the last comes out as its thing, like I2, if it is bromine, Br2, like this. See, who is at this last? I2. So here if there is I minus, I2 can come out. But here what we have? Br minus and I2. So who will come out first? Like if there is I minus, I2 will come out. But do we have here I minus? So it means there is no change here. So it means Br minus remains as it is, because I2 as it is we have now. If, see, very simple, give me 1 minute. NaCl plus Br2 gives rise to NaBr. Just listen this question, one question will enough for this. NaBr plus Cl2 NaCl plus out of these two reactions, tell me which is possible. Out of these two reactions, which is possible, I am asking. You just answer me this so that you will get that answer. What makes the difference? So you got now, here it is Cl minus, here it is. So who will come out first? Br minus when I compare with the Cl minus. So that's why Br minus is converting into Br2 here. Cl minus will convert into Cl minus. So which reaction is possible out of these two? Second. So which is spontaneous here? Second. Next, one more reaction I will add for the same thing. Is this clear up to here? Yeah. NaI plus Br2 NaBr plus I2. Next, NaCl plus I2 NaI plus Cl2. Yeah, tell me whether these two reactions are possible or only one is possible or none of them are possible. So what I told you, I minus is there here, so that will deposit first. So I minus can convert into I2. So it means this reaction is possible. Next, see, this one is chloride ion is there. Yeah. So will chloride ion comes out? No. It is at here now. If there is I minus, that will comes out. But here Cl minus, it will be at this side, it won't comes out. Okay. But if I do the same reaction with fluoride ions or fluorine, what comes out here? Yes, NaF plus Cl2. So this is how you need to identify which is a spontaneous reaction, which is a non-spontaneous. Is this clear or not how we are doing? So just follow this trend. The one which is at the last, that ion will comes out as its molecule, like I2, Br2, fluoride ion, like that. Okay, right. Is this clear or not, everyone, whoever followed? If not, you tell me, once again I will tell you. What is the simple trick, ma? The one ion which is at the right side will comes out first. So now, here if you observe these two reactions, in this first reaction, what we have here? This is at here. With which ion we are reacting? This side ion or this side ion? So if ion is at right side, see Br2 now, yeah. So it will convert into ion. So here what I am saying, this chloride ion is there now, this side. This ion won't comes out. If this side ion is there means only it will comes out. So here if you observe both of them, bromide ion and chlorine, which comes out? Bromide ion, because it is less electronegative, so comes out first. That's it. Okay, one last reaction, you tell me. Out of these two reactions, which is possible or spontaneous? Perfect. That's it. Everyone clear with this? Yeah, that's it. Read this question. A solution of copper sulfate is stored in a vessel made up of nickel metal. So is it possible to store? See, generally we will make pickles at home. So what happens when you keep that pickle in the some iron stainless steel materials? If it is not really good material, it will get rusted. Yes or no? Like spoons, you will be seeing some rust. So with the help of this, you can also get some clarity. See, can a solution of metal, 1 molar copper sulfate can be stored in a vessel made up of nickel or not, they are asking. See, what they are asking, copper sulfate in what? Nickel metal. See here, whether it is possible or not means, if the reaction is taking place spontaneously, so we should not keep it. It means what? Nickel vessel, if it is undergoing oxidation, what happens to that? It will convert into +2 ion. If it is converting into +2 ion means that whatever the vessel is there, you are going to have some holes to it now. Why holes? అరే నికెల్ విజిల్ ఉందిరా, దానికి ఏమవుతుంది, ఇప్పుడు ఆక్సిడేషన్ అయింది అనుకో, అక్కడ ఉన్న మెటల్ అంతా కరిగిపోతుందా లేదా, అప్పుడు ఏమైనట్టు ఆ విజిల్కి అది పాసిబుల్ అవుతుందా పెట్టడం, పెట్టద్దనే కదా అర్థం. సో దట్ ఈస్ వాట్ దే ఆర్ ఆస్కింగ్. కెన్ ఏ సొల్యూషన్ ఆఫ్ కాపర్ విజిల్ స్టోర్డ్ ఇన్ ఏ copper solution can be placed in a nickel vessel or not, they are asking. So how to check these? So just check their metal reduction potentials. Who is having more reduction potential? Copper or nickel? So copper reduction potential is more now. See, Cu plus 2 converting into Cu. How much it is? Plus 0.34. So nickel plus 2 converting into nickel. How much this is? Minus 0.25. So which is having more reduction potential? Copper is having more reduction potential means this metal will undergo reduction. If this metal is undergoing reduction, the other species will undergo oxidation. So here +2 is there. If this metal is undergoing reduction means nickel should undergo. So it means what happens to the vessel now? Get damages. So getting damages means we should not use that nickel vessel to store copper sulfate solution. So is this clear or not? This model questions you will see 4 statements. Which are the following statement is incorrect? The first statement will be like this. Write the 4 statements, otherwise I will make. First statement, zinc sulfate solution, which are the following statements are correct? Which are the following statements are correct or possible? Correct or possible? First statement, zinc sulfate solution can be stored in copper vessel. Can be stored in copper vessel. Copper vessel. Second statement, copper sulfate solution CuSO4, copper sulfate solution can be stored in zinc vessel. Can be stored in zinc vessel. Third statement, copper sulfate solution can be stored in nickel vessel. Copper sulfate solution can be stored in nickel vessel. Are all possible? All possible. Identify. So first of all, how to identify, tell me? అప్పుడు ఒక సిరీస్ రాసుకున్నాం కదా, అది పనిలేక రాయలేదమ్మా, ఇలాంటి క్వశ్చన్స్కి యూజ్ అవుతుందని రాసాం. అందులో ఇదంతా వదిలేయండి, మీకు రాసిన క్వశ్చన్ అట్లా పెట్టండి. జస్ట్ ఒకసారి సిరీస్ ఓపెన్ చేయండి. ఓపెన్ చేసి వీటిని రెండింటిని కంపేర్ చేయండి. నికెల్ ఎక్కడుంది, కాపర్ ఎక్కడుంది? నికెల్ +2 ఇక్కడెక్కడో ఉంటుంది, లాస్ట్కి ఇక్కడ కాపర్ +2 ఉంటుంది. ఈ రెండిట్లలో ఎవరు ముందు డిపాజిట్ అవుతారు? వన్ విచ్ ఇస్ అట్ ద రైట్ సైడ్. సో ఇది డిపాజిట్ అవుతుంది అని అంటే ఇట్ ఈస్ కన్వర్టింగ్ ఇంటూ కాపర్ మెటల్ కదా. సో ఇప్పుడు ఇది కాపర్ మెటల్ అవుతుందంటే నా విజిల్ దేంతో తయారు చేసా? నికెల్తో. అదేమవ్వాలి? ఇది రెడ్యూస్ అవుతుందంటే అదేమవ్వాలి? ఆక్సిడైజ్ అవుతుందంటే నికెల్ విజిల్ డ్యామేజ్ అయినట్టే కదా. సో ఐ కెనాట్ యూజ్ దట్ అని అర్థం. ఇప్పుడు ఇదే స్టోరీని మీకు ఇచ్చిన స్టేట్మెంట్స్కి అప్లై చేయండి, యూ విల్ గెట్ ద ఆన్సర్. ఫస్ట్ స్టేట్మెంట్ చెప్పండి. జింక్ Zn plus 2 ఇచ్చిన ఇంకోటి జింక్ సల్ఫేట్ ఇన్ కాపర్ సల్ఫేట్ అన్న. సో no once read the statement once again. Copper vessel. Okay, next second statement you read. Okay, see which ion is at the right side? Right side ion will deposit first. So this is at the right side ion now. So this will deposit as copper metal. If it is depositing it as a copper metal, our zinc metal will converts into Zn plus 2 ion. అర్థమైందా కాలేదా? The ion which is at the right side will deposit as the metal. The other substance will undergo oxidation then. Because this metal is undergoing reduction now, the other substance should undergo say copper plus 2 ion is at the right side undergoing reduction means, so zinc metal should undergo, so our zinc vessel will become damaged. So it is not good to store copper sulfate solutions in our, is this clear or not? So this is not possible, yeah, but this can be possible. Okay, is this clear? Okay, just check for the fourth option, the last second third option. Yeah, the remaining thing we will continue in the last session, study over.